Bright Duty. Every student matters.
So there are blood groups of 30 students of class 8th. These were recorded, okay, and these are written in this raw form. So there was a student who has got a blood group A, so I wrote A. Then there is a student who has got blood group B. B is written here. We need to represent this data in the form of a frequency distribution table, which is the most common and which is the rarest blood group among these students. So if you start looking at this data now and try to find out which is the rarest blood group, okay, you won't be able to interpret it that easily. But if I represent it in the frequency distribution table, we will see how easy it becomes. So I'll write blood group here and frequency here. What is frequency? Number of students who have got these blood groups. Number of students out of those 30 students, okay. So if I write blood group A, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students are there in class 8th out of these 30 who have got blood group A. So I'll write 9 here. Okay, let me complete the table. Right? What about the next blood group? Let me write B. Blood group B. How many students are there with this blood group? 1, 2, 3, 4, 5, 6. So there are 6 students who have got blood group B. What is the next blood group? O. How many students? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 students who have got this blood group O. And what is the next blood group? AB. How many students? 1, 2, 3. So there are 3 students who have got blood group AB. If you add these frequencies, it will give you total number of students. Total number of students. 12 plus 3 is 15, plus 6, 21, 21 plus 9 is 30. So yes, this is correct table. Okay, so we have written the blood groups of 30 students in terms of this frequency distribution table. Okay, now let us interpret which one is the most common blood group. The most common blood group will obviously be the group which has got highest frequency. Okay, so what is the highest frequency here? 12. So this is the most common group. Most common blood group is O. Okay, and which one is the rarest, of which the frequency is lowest? So lowest frequency is somewhere here. So this blood group is the rarest blood group is AB. And this is not a general statement that in the entire universe or in the entire world there is a rarest blood group is AB. No, we are just talking about these 30 students. Out of these 30 students, the rarest blood group is AB and the most common blood group is O. Okay, so always keep in mind that we are talking about the data of these 30 students only right now. Okay, so this is how you will interpret it. Distance in kilometer. 0 to 5, 5 to 10, 10 to 15, 15 to 20, and then let us make one more, 20 to 25, then 25 to 30, 30 to 35. I don't think there is any data which is more than 35. So this much classes would be enough. Now, number of engineers. or in other terms we can say frequency. So now, how many engineers live at a distance of 0 to 5 kilometers from their places of work? So 0 to 5, when I say, I will exclude 5, right? So I am looking for numbers below 5 here. So 1, 2, 3, 4, 5. Okay, I've got only 5 numbers which are below 5. So I'll write 5 here. Between 5 to 10. Now in this class I will not include 10, but 5 will obviously be included. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 engineers are there who live between 5 to 10 kilometers from their places of work. Now 10 to 15, this time 10 will be included but 15 will not be included. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 engineers are in this class. 15 to 20. This time 15 will be included but 20 will not be included. So between 15 to 20 we have got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 engineers are there in this class. Between 20 to 25, this time 20 will be included. So 1, only 1 engineer is there in this class. 25 to 30, 1, only 1 is there. And 30 to 35, I have got 1, 2. Now if you add these numbers, you will get 40. You can check it yourself. 22, 27, 30, 40. Right? So this is the data in grouped frequency distribution form of these engineers. What main features do you observe from this tabular representation? That is, how can you interpret this data? So one of the ways is like this. If you calculate the engineers living between 0 to 20 kilometers from their places of work, then it will be these engineers. 22 plus 9, 31, 36 engineers out of these 40 live within 0 to 20 kilometers from their places of work. So this is what we can observe. Beyond 20 kilometers, there are only 4 engineers. Okay, and you can keep on making these observations. If I ask you how many engineers live beyond 30 kilometers from their places of work, you will say 2, right? So this is how you will interpret this data. Let us move to the next one. The relative humidity in a certain city for a month of 30 days was as follows. So these are the relative humidities in percentage. Okay, construct a group this frequency distribution table with classes as 84 to 86, 86 to 88, etc. So let me form this class distribution table. So what do these classes represent? 84 to 86, this is relative humidity, right? Relative humidity in percentage. So I'll write 84 to 86, 86 to 88, because what is the class size? 86 minus 84, it is 2. So I'll maintain that class size and write the classes. 88 to 90, 90 to 92, 92 to 94, 94 to 96, 96 to 98, and 98 to 100. Now look at the data. This is the data for 30 days, right? So number of days when the relative humidity was between 84 to 86. Obviously 86 will not be included in this class. So I am looking for data points which are between 84 to 86. Okay. 84 to 86. One. Only one. That means there was only one day out of these 30 days on which relative humidity was between 84 to 86. Now 86 to 88. 1. We are looking for numbers that are 86 or more but less than 88. So only one day. 88 to 90. This one. And this one. Only 2 days. 90 to 92. 90, 90 to 9 to 92. 1, 2, 'That's it. 2 days. 92 to 94. 1, 2, 3, 4, 5, 6, 7. So there were 7 days on which humidity was between 92 to 94, and 94 to 96% humidity was on 1, 2, 3, 4, 5, 6, 6 days, right? 96 to 98 humidity, 1, 2, 3, 4, 5, 6, 7 days. And the highest percentage of humidity, 98 to 100%, was on 1, 2, 3, 4, on 4 days. Okay, so how many days in total were under observations? 1, 2, 4, 6, 13, 19, 26, 30. So total 30 days. data is this. Now this is the grouped frequency distribution table, where this is the frequency and these are the data points. Okay, so this is the grouped frequency distribution table with these classes. Which month or season do you think this data is about? As you can observe, the relative humidity is more than 80% on all of these days, all of these 30 days, right? So this happens generally in rainy season when the humidity is on higher side. So this month or this season is rainy season. What is the range of this data? So we will look for the highest number or highest data point and the lowest one. Then we will subtract the lowest from the highest to get the range. So which was the lowest? Obviously it was between 84 to 86, and there was only one such number, that is 84.9. So lowest we have is 84.9, and what is the highest? Highest will obviously lie between 98 to 100. So let us look for those numbers. This is 98.1, 98.6, which is closer to 100. 99.2 is even closer. And is there any number which is bigger than 99.2? No. So highest is 99.2. So to get the range, I just need to subtract 84.9 from 99.2, and it will give me 3, 4. So 4.3 is the range. Okay, 84.9 to 99.2 was the variation, and 4.3 is the difference between upper or the highest and lowest. Okay, so this is the range. The heights of 50 students measured to the nearest centimeters have been found to be as follows. So these are heights in centimeters of 50 students. Represent this data given above by a grouped frequency distribution table, taking the class intervals as 160 to 165, 165 to 170, etc. Okay, so let us make these class distribution table. So what are the classes? 160 to 165, 165 to 170, 170 to 175, 175 to 180, 180 to 185. Do we require more than 185 here? No, I don't think so. If we require it, we will create another class. Okay, so what do these classes represent? These are heights in centimeters. Okay, so height in centimeter, and these are number of students, or we can also say frequency. So how many students have got heights between 160 to 165 centimeter? See, we have got numbers below 160 also. So let us create some more classes so that we can accommodate these numbers. We have to create classes like 155 to 160, 150 to 155. Do we have number below 150 also? No. So this is enough. Now these are heights in centimeters, and these here I'll write the number of students. So 150 to 155. Obviously in 150 to 155 we will not include 155, right? 155 will be excluded from this class. So we are looking for numbers below 155 and equal to or above 150. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 students who have got heights between 150 to 155 centimeter. Okay, here I have written number of students. Now 155 to 160. So this time we will include 155 but exclude 160. So 155, there is this number which is between 155 to 160. 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 students who have got heights between 155 to 160. 160 is excluded from this class. 160 to 165. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 students are there in this class. 165 to 170. 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. Now 170 to 175. So 1, 2, 3, 4, 5. Is there anyone else? We can confirm it by adding these. So this will give us the sum. This should give us the sum 50. 12 plus 9 is 21, 25, 35. Yes. So these are the classes that are required for this table. Okay. We start from 150 to 155, then go up to 170 to 175, and all the data is exhausted in this table. So I have represented this data in grouped frequency distribution table, where this side or this column gives me heights of students in centimeters and this column gives me number of students or the frequency. Now look at this. What can you conclude about their heights from this table? So what can you conclude? We can say that number of students who have got heights more than 170 are only 5. Most of the students have got heights below 170 centimeter, or we can give the specific number also, that there are 35 students, there are 45 students, who have got height below 170 centimeter, right? So these are the observations that you can make from this table. Okay, and another observation, you can keep on making these observations. You can make one observation that there is no student who have got height more than 175 in centimeters obviously, and there is no student who have got height below 150 centimeter. And when I say these things based on this data about these 50 students. Okay, so I hope I have made it clear to you. Now let's move to the next one. A study was conducted to find out the concentration of sulfur dioxide in the air in parts per million, which is also known as ppm, of a certain city. The data obtained for 30 days is as follows. Make a grouped frequency distribution table of this data with class intervals as 0.00 to 0.04. Okay, so ppms is between 0.00 to 0.04 for how many days? We will write it here, number of days or frequency, right? Another class will be 0.04 to 0.08, 0.08 to 0.12, 0.12 to 0.16, and 0.16 to 0.20. Is there any number which is above 0.20? Yes. So 0.20 to 0.24. Do we require more than 0.24 also? We don't, but if in case we require it, we will add that class. So 0.002 to 0.04. 1. Obviously, we will not include 0.04 in this class, as I have explained earlier also. So 0.03 is included. This is not included. There is this number which is included here. Another number which is between 0.00 to 0.04. So I've got 4 numbers or 4 data points which are between 0.00 to 0.04. So I'll write 4 here. And what does it mean? That there were 4 days out of these 30 days on which the concentration of sulfur dioxide was between 0.0 to 0.04 ppm. Okay, this is how you interpret this. So 0.04 to 0.08. Now this time I'll include this also. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So on 9 days the ppm was between 0.04 to 0.08. Now 0.08 to 0.12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 such days. 0.12 to 0.16. So this time 0.16 will not be included, but 0.12 will be included. 1, 2, there are 2 such days. 0.16 to 0.20. So this is 1, 2, 3, 4, and 0.20 to 0.24 will have 1, 2, only 2 days. So we will add these and verify that the total comes to be 30. 18, 20 and then 28, 30. Yes. So total number of days are 30, and I have written this data in form of frequency distribution table, or specifically grouped frequency distribution table, and the group size was already given. So we started with 0.00 to 0.04 and continued that distribution. For how many days was the concentration of sulfur dioxide more than 0.11 parts per million? So we will look for 0.1. Obviously, these data points or these many days had more than 0.11 ppm of sulfur dioxide. So 2 plus 2 is 4, 4 plus 4 is 8. So there were 8 days on which it was more than 0.11 parts per million. But this data might be confusing because 0.11 lies in this interval also. So you will have to manually count on how many days the concentration was more than 0.11. Okay, obviously when we are talking about more than 0.11, we will not include 0.11. So we will start with 0.12, right? So 0.12 is fortunately the upper limit of this interval, okay, which is not included here, and it is included here. So 8 is the correct answer. I hope you have understood what I am trying to tell you. So there were 8 days on which the concentration of sulfur dioxide was more than 0.11 ppm. Okay, so what I did here was more than 0.11 means you start with 0.12 or more, right? So the lowest can be 0.12. So I am starting with this lower limit of 0.12 and counting the entries which are above it. So 2 plus 4 6 plus 2 8. The answer is 8, right? Now 3 coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted down as below. Okay, 3 coins were tossed 30 times simultaneously. That means you have 3 coins, let us say, and you toss them simultaneously once and note down the number of heads. It can be either 0 heads, 1 head. There are 3 coins. Okay, on one coin, let us say you have got tail. On the second, let us say these are 3 coins. You toss them and you get this result: tail, tail, and tail. Okay, this is about first toss or one toss. So how many heads did you get here? 0. Or you can get 1 head and 2 tails, right? You can get 2 heads and 1 tail, or you can get all heads, that is 3 heads. So the number of heads you can get is 0, 1, 2 or 3. Okay, and these are 30 such tosses. In this toss you got 0 heads, in this one you got 1 head. On any of these coins it can be. So we need to prepare a frequency distribution table for this data. Okay, so what will we have in our frequency distribution table is we will have number of heads 0, 1, 2 or 3, right? And how many times or the frequency of this result, 0 or 1, 2 or 3. So how many times did we get 0 heads? 1, 2, 3, 4, 5, 6. Okay, this is how we will prepare this frequency table. 1 head, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times we got only 1 head. 2 heads, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there were 9 times we got 2 heads. And all heads, that means 3 heads, 1, 3, 4, 5. There were 5 times we got heads on all the coins, and their sum should give me 30. So let us check. 6 plus 5 is 11, 11 plus 9 is 20, 20 plus 10 is 30. So the total number of tosses is 30, and this is the frequency table. This is number of tosses, obviously of 3 coins simultaneously, right? So this is the frequency table. The value of pi up to 50 decimal places is given below: 3.1415925 and it goes on and on. Okay, up to 50 decimal places it is written here. Otherwise we know that pi is an irrational number. Okay, it will not stop here, right? It will continue and not in a particular pattern. Okay, there you will have more and more digits after this also, but we are given only up to 50 decimal places and we need to make our observations on this given number, right? Make a frequency distribution of the digits from 0 to 9 after decimal point. So the first thing that we need to do is we need to write the digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the digits that can be there. And now we will write the number of times these digits appeared after the decimal point. So number of times or the frequency of these digits appearing. So 0 was present 1, 2 times. So I'll write 2 here. 1, 1, 2, 3, 4, 5 times. 2 was there 1, 2, 3, 4, 5 times, right? So you will keep going on like this. You just have to count how many times the digits appeared. So now I'll count how many times 3 appeared after this decimal. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 4, 1, 2, 3, 4. 4 appeared 4 times. What about 5? 1, 2, 3, 4, 5. 5 appeared 5 times. Now what about 6? 1, 2, 3, 4, 6 came 4 times. 7, 1, 2, 3, 4, 4 times. 8, 1, 2, 3, 4, 5, 8 came 5 times. And what about 9? 1, 2, 3, 4, 5, 6, 7, 8. 8 times. Okay. Now if you add these numbers, it will give you 50. Okay. So you can verify it here. This is 10. It makes it 20, 29, 33, 37, 42 and 50. So yes, this is the frequency table. Okay. What are the most and least frequently occurring digits? So look at the maximum frequency. Maximum here is 8. 8 and 8. There are two numbers, there are two digits, 3 and 9, which have got maximum frequency, or these appear most frequently. 3 and 9 appear most frequently. And what is the least frequency here? 2. So the number with least frequency is 0. For the digit that appears 0 appears least frequently, right? So this is how you will interpret this data. "30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows." So these are the number of hours they watched TV in the previous week. Make a grouped frequency distribution table for this data, taking class width 5 and one of the class intervals as 5 to 10. So are there numbers below 5 also? Yes, there is number below 5 also. So I'll start with 0 to 5. So number of hours 0 to 5, 5 to 10, 10 to 15, 15 to 20. Is there anyone who has watched more than 20 hours? No. So this is number of hours, and on how many days? Number of days. Number of children who watched TV between 0 to 5 hours is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 children who watched TV between 0 to 5 hours in the previous week, and between 5 to 10 hours the TV was watched by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students. And 10 to 15 hours, 1, 2, 3, 4, 5, 5 children who watched TV between 10 to 15 hours. And are there students who watched more than 15 hours also? Yes, 1 who watched for 15 hours, 2. So there were 2 students who watched for most number of hours, that is 15 to 20 hours. Is this sum equals 30? 10, 15 and 15, 30. Yes. So this is the grouped frequency distribution table for total 30 students. Okay. How many children watched TV for 15 or more hours a week? So these are the children who watch TV for 15 or more hours a week. That is 2. So answer is 2. Okay. Okay. A company manufactures car batteries of a particular type. The lives in years of 40 such batteries were recorded as follows. For example, 2.6. So this is 2.6 years, okay, for a battery, and 3 years this another battery lived, 3.7 years, and so on. We need to create or construct a grouped frequency distribution table using class interval size of 0.5 starting from the interval 2 to 2.5. So let me make it here itself so it is easier for me to count and write it here itself. Number of years 2 to 2.5, 2.5 to 3, 3 to 3.5, 3.5 to 4, 4 to 4.5, and 4.5 to 5. Okay, so let us see how many batteries were there which lived between 2 to 2.5 years. So number of batteries, or you can say frequency. So between 2 to 2.5, how many batteries? 1, 2, 2. Now 2.5 to 3, 1. This time we will not include 3, right? 1, 2, 3, 4, 5, 6. Now 3 to 3.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 such batteries which lasted between 3 to 3.5 years. And 3.5 to 4, 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11. Now 4 to 4.5, 1, 2, 3, 4, that's it. Now 4.5 and above, 4.5 to 5, 1, 2, 3, so there are 3 such batteries. Now I'll add these and check whether these are 40 or not. 8, 22, 33, 37, 40. So yes, these are, this data or this table is for the 40 batteries, right? So this is the grouped frequency distribution table for the lives of these 40 batteries, okay, where total batteries are 40. Okay, so this was about this exercise. Now I hope you have understood about what is data, what is the importance of studying statistics, how to present the data in class intervals, in grouped frequency tables and ungrouped frequency tables, what is class size, what is range of data, and lot of other terminologies that we discussed till now, right? Now we will meet in the next lecture. Thank you.